Realistic and Fruitful National Technology Day 2023. India has decided to be net zero in terms of carbon dioxide and other greenhouse gas emissions into the environment by 2070. This is only possible if we scale up nuclear power productions. Now, nuclear energy is the fifth largest source of electricity for India, which contributes about 3% of the total electricity generation in the country. As of now, India has 22 nuclear reactors in 7 power plants across the country, producing 6,780 megawatt of energy nuclear power. Now, the government of India has allowed joint ventures with public sector undertakings to enhance nuclear energy programs. As a result, NPCIL is now in 2 joint ventures with the NTPC and IOCL. Now, 10 indigenous pressurized heavy water reactors with a capacity of 700 megawatt are under implementation stages. If commercially successful, the nuclear power program could achieve faster and cost-effective applications. Thus, it may be possible for us to achieve net zero by scaling up nuclear power production to a level of 50% by 2070. Technically, the development of nuclear power plants involves complex technical challenges, including the design, construction of reactors, management of nuclear waste, and the maintenance of nuclear safety standards. To overcome these technological challenges faced by nuclear energy sector, India needs to focus on innovation in reactor design, waste management, and safety systems with deployment of advanced technologies. Hence, a right person with right perspective for the right objective in the right time has been chosen for delivering a talk on this special day, the National Technology Day today. Yes, Sri D.K. Shukla, Chairman Atomic Energy Regulatory Board, has been chosen by HBNI for delivering a special lecture on nuclear regulation in India, evolution to maturity. First of all, I thank Sri D.K. Shukla for accepting our invitation. Amongst his busy schedule, he has accepted it, and I welcome him for today's Technology Day celebration organized by HBNI. Welcome, sir. I welcome our Honorable Vice Chancellor, Professor U. Kamachi Mudali, to assume charge today morning in the auspicious days of Technology Day today. I welcome him. I welcome our Dean, Professor P.D. Nayak, and Associate Dean, Professor D.K. Maiti, who are going to present the introductory remarks and the vote of thanks for this event. I welcome all our DAE family members, scientists, and administrative officers from various units, NPCIL, AARB, BRC, HWB, and other DAE organizations. I welcome all associate deans and assistant dean of HBNI, administrative staff from HBNI, and HRDD for today's event. I welcome our doctoral students and training school officers and faculty members of HRDD and head of HRDD for this event. Before I conclude my formal welcome address, I'd like to add one more additional information. Today, 11th May, is the birthday of a great theoretical physicist and Nobel laureate, a great teacher, a man who altered the way science understands the nature of waves and particles, who is none other than Dr. Richard Feynman. Without studying his textbooks on Feynman lecture series, I doubt one cannot become a physicist. He was born on May 11, 1918. His famous quote about technology is, "For a successful technology, reality must take precedence over public relations, for nature cannot be fooled. Our responsibility is to do what we can learn, what we can to improve the solution and pass on them." With this, I once again welcome all our chief guests and one and all gathered here and join through the online link for HBNI's Technology Day celebrations. Thank you.
Thank you, sir, for deeply impressing upon the importance of the day. Your words have made us more receptive towards today's event. Now I would appeal to Professor P.D. Nayak, the Dean of HBNI, to enlighten us with his words and bring forth the importance of the day. Please, sir.
Good afternoon and welcome to HBNI Technology Day. This day is very important for all of us. Sanya Wilson, because of our Pokhran 1998. Now, this is the time that we have to convert our science into the technology. And HBNI is playing a crucial role. HBNI is playing a crucial role to bring all the faculty scientists of DA units on a single platform so that they can interact, and the basic science developed by the HBNI added institutes with the help of scientists from the R&D centers can be converted into technology. In last year, we have conducted 4 interaction meetings among the faculty and students of HBNI at various PIs and OCC of HBNI located at various places in India, right from the Chennai up to the Calcutta, Bhubaneswar, Lucknow, and many other places. And that was really successful things, and many basic science which are been carried out at the added institutes. They would join hands with the R&D centers like RRK, ERC, IGK. And I'm hopeful that in near futures, we'll get many patents which can be converted into commercial products. In fact, HBNI main role is to give the knowledge to various scientists, faculty in the advanced domain, which may be not possible if for the R&D centers or especially. We are regularly conducting the advanced lectures for the benefits of the scientists at R&D centers and other units of DAE. I request all of you take benefit of that lectures so that together we can move for peaceful use of nuclear energy, especially in the energy sector. Today lecture is really useful for all of us to take maximum use of the nuclear energy, maintain the regulatory aspect for the safety of the peoples of India, which are foremost, and we have always our nuclear reactors are very safe in the last 40 to 50 years, and we have maintained it. And that was possible because of our strong regulatory measures we have implemented before commissioning any nuclear reactors. Today also a special day for HBNI because today our VC, I was officiating for VC for last 6.5 months. And today we got a dynamic VC, former Vice Chancellor of VIT Bhopal. And he's our own person from DE. All of you know, I should not have to introduce about his role in DE. But after his assignment at Heavy Water Board, he had taken over as a Vice Chancellor VIT Bhopal, and he is with us. He joined today. So I pass on my responsibility to brief about this day to my boss now, Dr. Kamasi Madali. And I once again welcome our VC HBNI, Kamasi Mutri, to HBNI. And I quite sure with his leadership, HBNI will arrange many more programs, maybe many online courses for the benefits of our scientists, engineers at various DAVs. And we need all cooperation from all of you. And if you have any suggestion that if you feel that some of the courses HBNI has to take, please feel free to write to us. I am available up to 8:30 every day, or you can write to me dean@hbni.ac.in. We'll take your suggestion because whatever courses is should be beneficial to our scientists, engineers. It may be you are the best person to judge which are the courses you require, and if we have the required number of interested participants, we will arrange lectures either from the faculty from India, or if you have to hire some from abroad also, we'll do that. But we want what type of courses or what type of topics you would like to hear for your advancement of the whatever you are doing today, or take a vertical jump in what we are doing today. I wish you all of you happy Technology Day. Thank you.
Thank you so much, sir. We all really appreciate and admire your thoughts on how technical advancement led to nation building. Now, I would like to appeal to Professor U. Kamachi Modli, the Honorable Vice Chancellor of HBNI, to express his perceptions on this moment of National Technology Day. Please, sir.
Good afternoon. Distinguished gathering here. The chief guest and who will deliver the Technology Day lecture, Sri D.K. Sukla, who is a very good friend of mine, whom I know closely for many years in our department. The Registrar Selvin, the Dean Professor Nayak, and Professor B.K. Datta, who will be introducing the speaker, and D.K. Meiti, the Associate Dean, and the gathering here, students, scholars, and other invitees. I'm very proud to be here standing in front of you after assuming the charge as Vice Chancellor of the prestigious HPNA University. To say briefly that my interaction with HPNA University started in 2006, when formally the appointments took place for the academic responsibility. I was also one of the founding member of the Engineering Sciences Board of Studies under the leadership of Professor B.K. Datta. And since then, I have been associated with HPNI till 2017, when I became the Chief Executive and Chairman of Heavy Water Board, where that is not a constituent unit of the HPNI. I have guided, I think, nearly 13 PhD students and more than 26 MTech students. And in 2010, during the, I think 2015, when the 10th year of HPNA was celebrated, I was honored with the Distinguished Faculty Award. So I'm very proud today that coming back to HPNI, the parent institute, is a moment of joy for me. And I'm looking forward to contribute with all of you to the growth of technology, that what we can produce from our department to the nation's resources. Maybe briefly, I would like to say that on this Technology Day, one important thing that we should all know about is about what the whole world is looking, not only India, is on the circular economy. I think for the understanding of the young students here, you know, linear economy, that when you make a product, the product involves certain cost benefit analysis. It has a limited life. After some life, the product becomes obsolete and it is discarded as a waste. It goes to landfill and it may not be further used. Means resources becoming one way, and it gets larger in a place where it is not going to be reused. Today, everybody is talking about circular economy in all domains of science, technology, industry, and everywhere. That is how a product that has been made can be redesigned, rejuvenated, refabricated, or whatever way that you do, can use further the resources that are available with the product. or how we can maximize the efficiency of the product that when you make itself, that it is undergoing some design changes further, that you can reuse it for extending its life and it gives more benefit to you. So this is one of the thing that is catching up everywhere in the world, and the government of India, and if you all recall in 2021, our honorable Prime Minister made this statement that India should take all steps to progress in circular economy. How that has got relevant today on this technology day, that whatever product that we make in any technology, and that to preserve the technology, to utilize that product for its maximum resources, we have to design the product in the first phase itself that it will have an extended life. Second thing, that it should have provision for rejuvenation or redesigning and remanufacturing at later stage, that it can be useful for more years or more percentage of its efficiency. Today we have, I think, nearly 440 reactors operating all over the world. And if you take somewhere between 25 to 40 as the average life of the operating power plant, how far that we can extend its life beyond that, how far we can maximize the power generation from them beyond their, the limited period of operation as it was designed in the beginning, is a most important point that will come under circular economy. That you get more than what was designed for the power generation, as well as the cost that you put in investment, you should get more than that what you have you have put. Circular economy plays a key role. So everywhere in the whole world, people are now trying to redesign at some stage of the end of life of the particular plant or a component in the plant. I think in India, we have a very large number of examples, starting with RAPS and Madras Atomic Power Station. We have redesigned and refabricated our fueling system. And the whole world, many things have happened by which the life of a reactor is extended, and the power that has been surplus, whatever is produced, that adds to the economy of whatever that was designed in the beginning. This way, everybody is working on circular economy. One very important factor that we have to remember is that it has to have, particularly in our nuclear industry, that it should undergo a very stringent regulatory measures, because it's not like yet another industry like a chemical process plant or oil and gas plant or refinery that involves radiation. So we need to have an extra caution in undergoing strict regulation. So nuclear regulation, which is now today we are doing it under the purview of the Atomic Energy Regulatory Board, they also have to undergo a lot of changes when there is going to be an extended life of the reactor or extended life of a component, or redesigning and introducing the new component into an existing reactor, how all this will be fitting into to produce more power, or how we can increase the resource efficiency of the particular fuel or material or product like heavy water, whatever that is used in a nuclear power plant. This is very, very important, and for which the regulation has to be very strict and it has to be at its maximum flawless. So I'm very proud that today Sri D.K. Shukla is going to address the concept of this nuclear regulation in India, that is evolution to maturity, that how far we have started and how far we have come. And I hope that he will also address that how far we are going to see in future, maybe in the next 10, 20, 30 years, when our number of aging plants are going to increase, that we will have matured way of regulation to see that we can have circular economy in our nuclear industry with more and more operation of the existing reactors to get more power, as well as it will also satisfy the economy and the government and the policy makers that nuclear industry and nuclear power plants are a successful route for power generation. This is very important for us to survive in this world of competition, tough competition from renewable energy, other sectors like solar, gas, the biomass, and the other, whatever renewable energy sources that are coming today, including wind. So we have to compete with all of them with respect to the economy point of view, the cost benefit analysis. And I'm sure that with this new arena of the circular economy to have more and more benefit from the nuclear power plants. Nuclear regulation is very, very important. And as like all of you here, I am also very eager to look at the lecture of Sri D.K. Shukla and how we have matured and also how we are going to progress further in the years to come to have the attainment of the circular economy in nuclear industry. Thank you very much for joining today. And this is a very auspicious day for us, the National Technology Day. And we are very proud that our chairman of the Atomic Energy Regulatory Board, Shukla, is giving this talk. And thanks for joining once again. Welcome.
Thank you so much, sir. Your address was very encouraging and appreciative towards everyone working in the area of science. The day has gained a lot of friction since your speech. To express the HBNI's gratitude, I now request Professor U. Kamachi Modali, the Honorable Vice Chancellor, to present the welcoming bouquet to the guest of honor. Please, sir. Thank you so much, sir. With this, we are moving towards the integral event of the day, which is a special address by Dr. D.K. Shukla, Chairman AERB, on the topic Nuclear Regulation in India, Evolution to Maturity. And to introduce our esteemed and dignified speaker, I request Professor B.K. Datta, HBNI, to the podium. Please, sir.
Well, Namaskar. I've been asked to introduce my old friend, Sri Dinesh Kumar Shukla, to this gathering, which it really doesn't require any introduction, but we have to go through this as a formality. Generally, it is said, as you know, the application of science is engineering. Application of engineering is technology. And application of technology is the product. This product could be nuclear reactor, could be submarine, could be vaccine, anything product. So one has to work all these three domains, science, engineering, and technology, to get a good product. If any of these links are weak, you will not going to get a good product. And we have a chief guest today who has practically either he has worked or at least got associated with all these three domains. So there is a reactor physics, with a reactor engineering, where it's a reactor operation, where it's a reactor maintenance, and so on. So all these three domains Sri Shukla has either worked or associated with. Now, just to introduce him to this gathering, Sri Shukla graduated from Government Engineering College, Jabalpur, Madhya Pradesh. Those days, Madhya Pradesh and Chhattisgarh was a single state. It was in mechanical engineering in 1980. He joined the Bhabha Atomic Research Center in 1981 through 25th batch of BRC training school. As a part of his assignment in BRC, he has been associated with the commissioning of high flux research reactor and later held the positions of reactor superintendent and head reactor operation division. As head ROD, he was responsible for the safe and efficient operations of the research reactors. He has been also associated with the several committees of AERB and BRC Safety Council for the design and operational safety review of pressurized heavy water reactors, light water reactors, special facilities, reprocessing plants, and radioactive waste management facilities. He was also the chairman of the advisory committee on the occupational health for BRC facilities and unit level safety committee. for medical and other facilities. He was a member of the management committee for the Board of Radiation and Isotope Technology, that is BRIT, and also of the Radioisotopes, Radiation Technology and Application Committee of the Board of Research in Nuclear Sciences, that is BRNS. He immensely contributed toward the development of various safety documents in BRC. Subsequently, after his BRC assignment, Sri Shukla joined AERB in 2015, where he served in various capacities as the member of the board, executive director, and chairman of the safety committee for the operating plants, that is called SARCOM. In February 2021, Sri Shukla superannuated from AERB and subsequently actively monitored nuclear energy professionals and nuclear safety and regulations. Related to his international assignments during this period, both as BRC as well as AERB, Sri Dinesh Shukla served as consultant to the IAEA on matters related to safety of research reactors. He led the Indian delegation during the 7th organization meeting of contracting parties on the Convention of Nuclear Safety. He represented India in the meeting of OECD CNRA Task Force on Research Reactor Safety. He chaired IAEA workshop on regulatory supervision of research reactors held at Vienna. He also chaired the organizing committee of AERB for the International Conference of Kansas in 2015. Government of India appointed Sri Dinesh Shukla as internationally acclaimed expert in the field of nuclear safety as the new AERB chairman on 1st January 2023. Thank you very much.
To please come to the podium and give his special address. Please, sir.
Hello. Hello. Hope it's working. Okay. So good evening and wish you all a very happy Technology Day. Already about Technology Day, a lot of things have been said, so I won't repeat. Only what I would say is that Pokhran tests were culmination of a series of long-term activities such as production of input material, conversion to special nuclear material, its extraction, making the device, and finally conducting the test. But to the forefront, only conducting the test comes. Many of us also might have been associated with some of these activities, these chain activities, what I said. So I express my gratitude to all those backstage contributors also. Besides commemorating Operation Shakti, Pokhran 2 nuclear test of 11th May 1998, celebration of this day also aims to recognize scientific and technical achievements. You must be wondering that how the topic of today's talk, nuclear regulation in India, evaluation to maturity, relates to this. Because we are supposed to talk about the achievements, scientific achievements in science and technology. So let me try to explain. Since influence of regulation on technology development as well as the deployment is critically dependent on the way regulation is done. I think that is what Dr. Kamachi Mudali was trying to bring in, how regulation is related to this. So since the influence of regulation on technology is critically dependent on the way regulation is done, therefore, regulation in itself is a technology. And that is the justification why this topic is relevant for today. And since the topic is nuclear regulation in India, evolution to maturity, and introspection is the way to become more mature. Let us begin with some introspection. So, what is the need to introspect? It is to understand rationale behind past actions, question their relevance in present times, avoid making the same mistakes, build on the successes, learn from experiences, and anticipate the future better. So, this is the need why we should introspect, and let us go ahead with that. So, first, see in retrospection the milestones of Indian nuclear program, and here you can see that Atomic Energy Commission was established right in 1948 under Department of Scientific Research, followed by establishment of Department of Atomic Energy and Atomic Energy Establishment Trombay in 1954. The first research reactor, Apsara, was commissioned in 1956, a first in Asia, and in 1958, the AEC was replaced with reconstituted AEC with full executive and financial power to plan and implement the various measures on sound technical and economic principles and free from all non-essential restrictions or inelastic rules. You see the bombastic wording in the 1st March 1958 resolution which was put to the parliament, with which AEC was reconstituted here. This reflects the importance given by the government to atomic energy. And with experience of concurrent development of technology and regulations in initial phase, to meet the requirement of regulation in expanding nuclear program, Atomic Energy Regulatory Board was constituted as national regulatory body in 1983. Nuclear Power Corporation of India, NPCIL, and Bharati Nabiki Vidyut Nigam, Bhavani, were constituted in 1987 and 2003 for deployment of water-cooled and sodium-cooled reactor technologies, respectively. So these were the milestones, and today where we are. Now you see where we are. The Indian nuclear program is largely homegrown, and this slide depicts the full capability or our national strength and self-reliance in the nuclear technology. We are capable of doing everything within the nuclear field. And most importantly, you can see that the base, everything I have kept above, the base is here, the human resource development and knowledge management. This is the unique thing with this department over which everything else is built up. So just recap of that foundation of Indian nuclear program, the robust R&D program, infrastructure for human resource development and knowledge management, fuel cycle capabilities from mining to waste management, industrial support, manufacturing and construction in every area. Now here comes the pearls of wisdom given to a young scientist of Heavy Water Board, and we have a former CEO of Heavy Water Board in front. So I think the right slide I have chosen. Where that the young scientist was having some inhibition to putting a order to a new company, and where that Dr. Sarabhai has brought it, that there is always a first time which should not come in the way for developing people and technology. And this wisdom continues throughout in the department till date. And Dr. Sarabhai played a pioneering role in institution building, as you have seen in the previous slide. That so many things could come up. That was the vision at that time. And as I said, the base of the whole program was the human resource and knowledge management. There comes the what our great founder said in 1944. When nuclear energy has been successfully applied for power production in, say, a couple of decades from now, India will not have to look abroad for its experts, but will find them ready at hand. Now you can see this has really materialized, and key role played by him that establishing the training schools right from 1957 itself. And today you have this great institution, HBNI, from where I am addressing to you. And we have the training school spread all over the India, having capacity of training more than 500 fresh engineers and scientists in a year. It's a great resource which other countries definitely lack. Coming to the genesis of nuclear regulation in India, how did we start? So first genesis is the concurrent development of technology and regulation. Here that regulation was not there. When we started, it was the first was the technology, and people were self-conscious. So safety was an important component of the R&D program. Vision of the early leaders was safety is the foundation for sustainability. Safety was taken as an important responsibility from the early days of the program. And when the first research reactor project Apsara started, the major concern of the engineers and scientists who were working on this project was public acceptance of new technology largely depended on the demonstration of safety execution of this project. This was the major concern they had, that in case anything goes wrong, then the whole technology will be thrown by the public. And that led to the cautious approach, exploration of options, threadbare discussion to pick the best option in every activity, And this was the first step to the conservative decision making. Now people talk big in that maintenance, this management parlance, that conservative decision making. It was the right way naturally there in the beginning itself in the department. Clearly defined objectives, involved personnel were aware of their roles and expectations. Safety during commissioning of Apsara was ensured essentially through self-regulation. For utilization of Apsara, weekly meetings of scheduling and clearing irradiation experiments were being conducted. Concept of safety committees started from here. And added advantage was the presence of chief architect of our nuclear energy program, Dr. Homi Baba. If you see that today, whatever we talk about the attributes for a organizational excellence, everything built in. Just in one slide, if you can see that involvement, that clarity in the goals and objectives, everything was very well there. Only difference now what you can see is one was that time that organization was very small. So informal way of doing things could have been accepted at that point of time, but may not be today. So that is what introspection is needed, and presence of Dr. Homi Baba, a person who had the total vision, overall picture. That's why he is called architect. Like an architect knows what he is going to do and how he is going to convert your house. That is the way that any doubt, it can be clarified, because there is a person who has the full picture. And that was the biggest advantage at that point of time. Apsara attained criticality, and Apsara was a major milestone because although there was no formal safety analysis report and no formal clearance was given for the first criticality of Apsara, it had all the safety features that were required in a research reactor at that point of time. Now you see where from it has come. This gives that the strength of the self-regulation. If you yourself are taking care of the safety, you can make regulator redundant, and that is what should be the prime focus. And you will see that how ERB is adopting this concept. This was the famous cartoon of Mr. R.K. Lakshman, which appeared in Times of India when Apsara was dedicated to the nation in 1957, with a caption that this is the one thing they have done in 30 years advance. So always we are remaining behind, but here it was put as that we have done 30 years in advance. And Apsara laid the foundation for training of scientists, engineers, and the infrastructure for the reactor technology. Then came the Cyrus, the next research reactor, workhorse or the foundation of the Indian nuclear power program, where Dr. Bhabha saw to it that as many parts as possible were made in India. Dr. Bhabha decided that unlike Apsara, where that fuel was imported, Cyrus should have Indian-made fuel elements. In 1959, he informed Pandit Nehru, then Prime Minister, I have little doubt that we will be able to make satisfactorily fuel elements. There are hardly 5 countries in the world which make their own fuel elements today. And you must be happy to note that the first 2 fuel elements made in AFD BARC, which were sent to NRX for irradiation, they claimed that this was the best fuel which were irradiated in NRX. Cyrus attains criticality in July 1960, formal design and safety report, first time in India. This is what I am trying, that how regulation slowly evolved. A formal reactor safety committee for research reactor set up by Dr. Bhabha in 1962. Program committee for review of proposal for reactor utilization and irradiation was constituted. Further approval was by the reactor safety committee. Any change in control system of the research reactors needed vetting by the reactor safety committee. So the emphasis on safety with a scheme of multi-tier review. Now you see this scheme of multi-tier review takes care of all checks and balances. When you have the multi-tier, if one tier misses something, at least next year catches it out. governing vision of nuclear safety regulation given by the Bhabha in 1960. Radioactive material and sources of radiation should be handled in atomic energy establishment in a manner which not only ensures that no harm can come to workers in the establishment or anyone else, but also in an exemplary manner so as to set a standard which other organization in the country may be asked to emulate. And when I will come to the concluding part, you will see that how what has been done really matches with what our great visionary founder had thought at that point of time. Just quickly going through the timeline of the evaluation of nuclear safety for DAE facilities. So TAPS 1 and 2, the TAPEX committee with Dr. A.K. Gaungli, Health Physics Division was there. And then committee for Tarapur was there, which was renamed for REPS 1 and 2 as DAE SRC. And its scope was expanded in 1975 to cover all DAE facilities. And there was a Makoni committee which recommended in 1980 the creation of AERB under AEC. And finally, 1983, Atomic Energy Regulatory Board was constituted, though DAE-SRC continued to assist AERB, and in 1988 only DAE-SRC got subsumed in AERB. Similar pattern for the regulation of radiation, where in 1963, Directorate of Radiation Protection, the DRP of BRC, was the actual regulator. In 1971, Director DRP was put as a competent authority under Radiation Protection Rules 1971, and based on the Makoni Committee in 83, AERB was set up, and this setup continued till 2001 when that regulatory function of RPAD was finally merged with AERB in 2001. So you can say practically, though the 1983 AERB was constituted, it became full-fledged regulator somewhere in 2001. The establishment of AERB in exercise of all power, blah, blah, with the Atomic Energy Act, emphasis is on the red part. Atomic Energy Regulatory Board, AERB, to carry out certain regulatory and safety functions. This is what is highlighted. There are multiple functions given in the Act. All are not given to the AERB to carry out certain regulatory and safety functions. And this, as we proceed, you will see the importance of this red lighted part. This is the main part, that organizational arrangement, that is the interface of AERB with the government. AERB is responsible to AEC, which is the apex policy making body, reporting to the Prime Minister, and within the limits of approved budget by the Parliament, the AEC has the power of the Government of India, both administrative and financial. DAE provides administrative support to AERB for interfacing with the government. This arrangement provides effective separation between the functions of the regulatory body and the organization concerned with the production of nuclear energy, that is DAE, without isolation. This is what is important, without isolation. Having a functional independence rather than the functional separation. On the cost of isolation, it is really a costly affair if you look for the circular economy, what Dr. Kamachi Mudali was bringing up. So these arrangements, whatever are in place, they provide adequate functional separation of the two different types of functions. Coming to the roadmap to safety regulation, AERB evolved from the scientific environment of concurrent development of technology and regulations. So it shares same DNA of scientific establishment and inherited the good practices of multi-tier system of safety review and assessment, regulations based on sound scientific principles, and the concurrent development of regulation with technology. ARB adheres to the key principles of functional independence and ensuring that the licensee is adequately discharging its prime responsibility for safety. Just represents how ARB is within the Indian states. So we have the headquarters here in Anushakti Nagar. We have two buildings already operational, A and B. The C building is ready and soon it will become operational. We have three regional regulatory centers, especially to cater the heavy demand of the radiation application field. Because that is spread over all over the India. So for that, we have created three centers, one in Delhi, one in Kolkata, and one in Chennai. And the jurisdiction is radiation safety all across the country and industrial safety in DA units. For non-DA unit, industrial safety is not under the purview of. Now coming to the major part which was being talked about, the reshaping of AERB, the thought process and new initiatives. Let us see the thought process which has been taken into account before we embarked on the major reshaping, that is somewhere in 2016 onwards. So the first thought was on the understanding the facts for continual self-assessment. The fact is, the license's good safety performance is not a certain indicator of effective regulation. So quoting all the time that NPCIL plants are operating very safely, it may be indication of effective regulation, but not certain. There could be some other, they themselves could have been by self-regulation may be operating. So that credit should not be straightway taken. So this is the first fact. The second is, conversely, licensees' bad safety performance definitely indicate ineffective regulation. If they don't perform safely, then definitely it is the ineffectiveness of the regulation. But if licensee's safety performance improves as a result of persuasion, enforcement, or other action by the regulatory authority is effective. This is the third bullet which we try to percolate down the ladder in the AERB. Then is the regulatory focus. Who is the focus of the regulatory oversight program? It is the licensee who has the primary responsibility for safety. Licensee's background, the maturity and safety performance are important factors in deciding scope and depth of regulatory attention. A graded approach. If the way a regulator deals with the NPCIL, it cannot deal with the other organizations come where they do not know the intrinsic knowledge of this nuclear industry. So what is the focus of regulatory oversight? The focus is to verify effective implementation of a licensee's management system of all phases of facilities life cycle, with particular focus on oversight of agencies involved in design, construction, commissioning, operation, and maintenance activities. AERB's oversight provides independent verification that requirements have been met, with emphasis on making the licensee aware of its primary responsibility for safety. We don't get into or take their responsibility, but keep on making them aware what is their responsibility. The regulatory supervision does not diminish the prime responsibility of the applicant or licensee for the safety of the nuclear and radiation facilities. The regulatory supervision does not substitute for the control, supervision, and verification activities that the applicant or licensee must carry out. This is ensured and made clear to the applicants and licensees through various regulatory processes. Influencing versus enforcement. The most appropriate regulatory focus is on encouraging the licensee to self-identify, understand, and take ownership of safety issues and improvements because it is the licensee who is primarily responsible for safe operation. However, a flexible approach is adopted as it is sometimes necessary to reinforce messages through formal processes, which may include enforcement tools. But this should be the very, very rare occasions. All the time, the first bullet should suffice. It is important to encourage the licensee to analyze perceived issues in more depth and reinforce the need for continuous rather than a one-time improvement program. Because many a times, whatever comes into the mind, an incident has taken place, just take over of that. But the repercussion, going in deep, you will find there has to be a continuous improvement needed rather than a one-time improvement. Then another important aspect before you embark upon the way you regulate, especially when it comes to the radiation application. The way you regulate the nuclear industry, the same methodology cannot work in the radiation application. And that I have tried to bring out that how these two are different. Now you see the nuclear industry, it is organized sector under government control. So fixing responsibility is very easy. Second, economic considerations are not that much because whatever you demand, they will be able to do it, which in a private sector it may not be possible. Decommissioning, you can have a planned system for generating the fund and ultimately carrying out the decommissioning. And most important is fixing responsibility is possible. And multiple facilities are at one side. So comparatively and less variety for nuclear facilities. So you can post the site observers there and have the good regulation. But when you see in the radiation application field, there is scattered sector, mostly unorganized, vast variety. Every day a new device or new thing comes into the picture. Almost every day you get something or the other new which is not matching with your earlier type approved thing. So scattered all over the India, so observers or frequent inspections not practicable, and they are mostly operated on leased premises. That is another problem. Today they are there, tomorrow they run away. Now that fixing the responsibility becomes very difficult. Now you keep on searching. So these are the differences which have to be kept in mind when you devise the regulation for radiation application. Next comes is the interfacing or overlapping with other control authorities or regulators is very limited in case of nuclear facilities. But when it comes to the radiation application, this interfacing, overlapping with other control authorities or regulators is significant. A large number of people are there or agencies are there. Then knowledge intensive with nuclear facilities or nuclear industry, trained and competent human resource available. A strong backup of R&D is available to them, which is missing in the case of radiation application being in unorganized sector. Low to moderate maturity, almost nil R&D backup for the radiation applications field. Then in nuclear industry, high level of maturity and safety culture, realization and in practice, the safety aids productivity. This has come in the nuclear industry. Being in organized sector, they could understand that the safety aids productivity. But this you cannot sell to the radiation application field because they are profit oriented, small, mostly individuals, non-technical people are running them. They are controlling the business. Difficult to make realize and much more difficult to translate in practice that safety aids productivity, which is much easier in the nuclear industry being in organized sector. And that's why the lack of safety consciousness. Because if you see that the number of excessive exposure cases coming from radiation application field is enormous. And it takes a lot of resources from AERB to resolve those cases, which are very much avoidable just by simple awareness. So these are the facts or focus which must be known before we devise the way we regulate the radiation application. Then coming to the key organizational attributes for effective regulation. Now, these are theoretical part before I embark on the what based on this has been done in AERB. So what are these? Clear and unambiguous vision, mission with well-defined organizational policies and core values. Well-designed organizational structure aligned with mission, vision and legal mandate. Defined roles and responsibilities with commensurate authority, centered around organizational policies rather than individual personalities. So structure is built around the vision, mission, goals and objective, not around the personalities. So and so is senior, so make a division to make him head. No, it should be matching with your mission and objective. Centered then selection of the, this is another important aspect, selection of right people for right job. Transparency and accountability in all actions. If roles, responsibilities and commensurate authorities are defined, automatically accountability comes into the picture. Stakeholders involvement, communication of right stuff at right time by right person. Another very important aspect. So these are the key organizational attributes for effective regulation. Taking all these things into the thought process, then we started revamping AERB. So first was the organizational restructuring, where we have organizational structure was reorganized and aligned with mission and vision and legal mandate. Creation of some new directorates took place and some were merged. Some old divisions have to be merged because we found that they are not useful or they are not directly giving the output. Providing inclusiveness and equitable career progression opportunities, because specialized disciplines, for them it was becoming very difficult, they are getting sidelined, those specialized people. So these specialized disciplines such as industrial safety, civil engineering, they were integrated with the core processes. So while keeping their specialization, like we say BSc, then MSc in a particular subject or MBBS in one and then having the post-graduation in some. So they are postgraduate in those subjects, use them as a over and above beyond that your basic MBBS degree. So that is the way career progression has been addressed. Optimal resource optimization, that is graded approach was brought in. Optimization of safety committees, the enormous, so many number of safety committees. Now they have been subject and vision, mission and objectives put together, they have been reduced drastically. Optimal, then enhanced employee engagement. This is one of the important thing that in the decision making that I will come later, that this part which was being done by the committees was shifted to the individuals in AERB. So impetus on self-reliance in regulatory decisions, responsibility of regulatory decisions, now more emphasis on in-house review, utilizing committees for next level review and recommendation, lead reviewer concept to coordinate the internal review and tap the knowledge resource available within AERB. Facilities wise, lead reviewers are appointed and communicated to the licensee, and they have the corresponding coordinator there who can coordinate with them. So many of the technical issues are sorted out before things are put up to the committees. Safety committees made recommendatory. Earlier they were having the executive power. Now they have been made recommendatory. Decision will be taken by the AERB and somebody will be who has been given the decision making authority. So accountability sets in. Graded approach in regulatory decision. This is a well guidance is made available, a big document on graded approach. Enhancement of participation of AERB staff as vice chairman, member of tier 1 and tier 2 committees. Practically wherever we have the senior people available, now they are either chairman or vice chairman, at least in the safety committee, so that you have the better control and focused discussions. So systemic and structured approach, www.h, that is why to do, what to do, when to do, and how to do. This is for every activity being applied. Then emphasis on key regulatory matters, the development of regulatory documents. Again, a big change over here. Earlier, there used to be a big task group form, and then they will start making, then you can say that when so many people are there, that responsibility is not well defined and nobody is responsible. And you can see our documents, there could be documents which have taken 15 years to come out. So now it has been changed. Now first draft is in-house. It has to be within the AERB. The nodal division will appoint 1 or 2 people. They will make the first draft. Then there will be a task force for further value addition, where they will have the experts from all the places wherever we can tap them. Overall strategy for uniformity, consistency among them, and also with legal instruments, well-defined terms, glossary, dynamic glossary we have put on our website, that as and when new term comes, let us put it so that it can be used by the people who are making the documents. And besides taking comments from known experts and stakeholders, draft safety codes are put on website for comment from wider section of the public. Now for 2 months, the draft codes are put on our website so that anybody can comment rather than safety review and licensing. That earlier there used to be a multiple times the same licensee has to come to AERB, one for license under factory rules, then one for the license or license renewal under radiation protection rule, and one for the waste authorization. Now everything has been synchronized and put together in one stroke, one review, all the 3 things will be done together. And strengthening of internal review by AERB staff. So technical authorization of staff and lead reviewers. This is not that just you have joined AERB, so you become regulator and reviewer and you get the authority. No, you have to go through a rigorous process through which you will be technically authorized that yes, now you are competent to be a reviewer. Regulatory inspection methodology paradigm shift. Now here we have divided this regulatory inspection in 2 parts. First part is the programmatic part, again where that www.h comes, that is why to inspect, what to inspect, when to inspect, and then how to inspect. So this part is continuously worked by a directorate which continuously work on taking inputs from safety review, incidents reporting, complaints, everything put together. They keep on what to inspect, when to inspect, how to inspect. Continuously they keep on working rather than the fixed cycle that in 6 months a big team will go and see. No, it is need based first. Then execution part, inspectors from all technical division. Now programmatic part is there. You have made that what is to be inspected, how it is to be inspected, when to be inspected, but then who will inspect? So their whole AERB participate. Now anybody who is in AERB is supposed to have that inspector license, and there is a process for getting that license. So a small team and targeted inspection areas, all facilities of that site covered. Now earlier again there used to be a different teams going. The industrial safety, a separate team will go. Security, a separate team will go. Nuclear safety, a separate team will go. Now no. Once the team goes to that site, they will have the integrated inspection of all these, plus all the facilities available on that site. So once they go that 4 or 5 members, then they will cover all the facilities in that stroke. So that optimizes the resources. And inspection of licenses at quarter also we have started. As I said that the design and other part was getting left out, which is being done. 2017 first time we had that NPCIL headquarter inspected, and then recently that follow-up inspection has been done. Report, very important part. Each observation is corroborated by a requirement specified in AERB's reg docs or other mandatory documents like technical specification. Whims and fancy and arbitrariness of the inspector has gone. If he has to put a recommendation, he has to quote it is against which requirement of AERB. So that has brought it in more focused way. and accordingly RI findings are following graded approach. They have been graded in different color codes. Like the highest one is the red. Plant cannot operate if there is a red finding. Then there is next is the amber, then coming to the gray, and then finally white, which is different. Now today you can see that our website, many of the things we put, not a single facility is there which is operating with a red finding. There is no red finding. Then only plants are operating. The day red finding comes, they have to shut down, which was not there earlier. Earlier, the gradation was 1 to 5 categories, and with the highest category available, still plants are operating. Now, today we can say that no red finding, that's why plants are operating. Then emphasis on key regulatory matters, off-site emergency preparedness and response. Here also there is a paradigm shift. That earlier, the way it was being done, now it has been broken into the two parts. That technical evaluation and decision making by the plant authorities. The template is altogether prepared by AERB, BRC, NPCIL, and DAE-CMG. While the second part, that is the execution in the field, the way it was done for the regulatory inspection, the programmatic and the execution. So implementation of response measures in public domain by district authorities. And there that part B, the DPR plan prepared and issued by NDMA in consultation with CMG, NPCIL, BRC, and AERB. So this is what we coordinated. And importantly, the whole methodology of exercise, emergency exercise methodology has been changed. Earlier it used to be with the known event. If this type of event is, everybody was knowing. So operators' response was not getting checked. Now it is against an unknown event. There will be the inject in the form of envelopes. The first envelope will be given to the control room. This is the event. Now you observe how they respond to it, because it is given offhand. They are not knowing that what was the scenario. Then it will be escalated by the second inject, second envelope, then third envelope till it goes to the offsite condition. One is, by doing that, people have found it very difficult to generate these envelopes, which can cause the offsite emergency. Now, when the operator sees these things, you see his confidence increases that my plant is very safe. It is very difficult to get to the offsite conditions. So that is a hidden benefit of this. Now coming to the very important part, which was related to which, while telling that constitution of AERB, some red part was there, certain regulatory functions, not all. So see that the act is for this purpose. If you see, the regulation has two components. People forget that there is another component. People think only safety regulation. No, there is a control regulation. Control is part of the regulation, where that what activities to be permitted. That is a control part, nothing to do with the safety. So that is governed by the national policies, safety, waste management, and other as applicable, including strategic requirements, international consideration, diplomatic terms with other countries with respect to trade and commerce, defense. So those parts regulatory, safety regulatory body cannot do. It is to be at the government level. So it goes to the different domain. Then who should be permitted? Now, like nuclear power, it is very clearly said that it is government company as on today, whatever our act is there. So that is who should exercise that. AERB cannot say, as long as people are fulfilling the safety requirement as per our code, we cannot deny them. So it is to be denied under the control, which license is to be given by the different agency. And once these two aspects are seen, what activities to be permitted and who should be permitted, then comes the safety in permitted activities. That is safety regulation. So there comes the AERB into the picture. This is what I was trying to make there clear. And that's why when it goes to the radiation application, then need this lot of inter-ministry coordination for approving justification of new applications, new practices, and clear understanding of control function and coordination for seamless regulatory interface. So how it is there in India? So you can say control of nuclear facilities. It is DAE, the first DAE license then only people have to approach to AERB for safety license. Control of radiation application, some part is with DAE, but many part is with the other line ministries under relevant law, like radiation generating equipment, their procurement, and that part is with the other line ministry. The transport, if you see that it is with the DGCA by air, the DGCA takes care. And then nuclear and radiation safety, that part only comes to the Atomic Energy Regulatory Board. And just I have listed out here what we have been working on, like NABL is the accreditation of labs. AERB was doing. AERB is not competent to have that ISO understanding, which is a must for that accreditation of labs. So we coordinated with NABL, and now this part is being done by them. Support is being provided by AERB. Similarly, DGCA responsible for transportation of radioactive material through airways. We have understanding with them and written and signed MOU that this part up to the airport they will take care. After airport, yes, AERB will come into the picture. We had initiated dialogues with the MORTHS for roadways transport. Similarly, other part is in the pipeline. IIP, already we have done an understanding that packaging of radioactive material part they will not be doing, though it is given to them also, but it will be by AERB. Just an example of interministerial part, how it is to be done. Increased awareness of stakeholder, what has been done over the years. AERB's website has been revamped, more user-friendly, more people-centric. Facts and myths have been brought out. Informative reading material for awareness of stakeholders made available on website. Advertisement in print and electronic media, radio jingles, short audio, video clips for social media, and influencing the licensee campaign continued to increase awareness and self-regulation in licensed diagnostic radiology facilities. So information leaflets on radiation safety Jagrukta Seva sent to the licensed radiation facilities. And for regulatory experience feedback, since 2017, we started an annual national conference on regulatory interface with a purpose to create a common platform for the licensees, vendors, suppliers, and the regulators to share experience feedback on regulatory requirements, emerging trends, and changes required in regulatory regime. Since 2021, besides annual conference, program is spread over full year through multiple webinars, VCs to cover wide range of interfacing, simplification of our electronic licensing of radiation application modules, regulation of dental X-ray practice has been simplified widely based on experience. A help desk has been established for providing regulatory support to users of especially radiation facilities. Then HR and knowledge management of staff is one of the most important which I see from the department's perspective. Management development program. This is the normal management. So residential 1 week program, we covered all the staff. Not a single person has been left out, including me. We had gone for 1 week to a place where in a batch we have gone through this management training, especially that soft skills. Then training basic to all advanced and advanced to selected officer of AERB officers by expert from IIT Madras on human and organization factors. Because this is one of the most important part which should be known. Because many of the events, when you really analyze them threadbare, you will find one of these factors will be the responsible rather than the machine. Because machine failure is very simple, which can be taken care of much easily. But HOF factors takes time to be corrected. But if they are corrected, as it was said, the continual improvement needed for HOF. Technical talks, colloquia by experts on topical issues, presentation of case studies on lessons learned from past accidents by young AERB staff. This is almost every month we have 2-3 colloquia. Then recruitment norms, mix of candidates at all levels. So we have taken even SOG level directly from the industry. Though we say from industry, but they are our people who had left earlier the DAE and then came back through this route. But we got back the same experienced people to us. So our knowledge management takes care. Though we get the people from training school, we have the we issue the circular for internal transfer from the DAE facilities. So in between we get them, then from the industry also. So all the time you will have the mix of होश एंड जोश दोनों चाहिए. सिर्फ ना तो जोश से पूरा काम होता है ना होश से पूरा काम होता है. काम करने के लिए जोश चाहिए और अच्छा करने के लिए होश चाहिए. तो वी हैव दैट मिक्स ऑफ होश एंड जोश टुगेदर ऑल द टाइम. Now, whatever I said that whatever reshaping has been done so far, whatever I tried to tell you, the reshaping done based on introspection and associated thought process should be sustained. How to sustain it? Today, I have some vision, I do something, tomorrow somebody else will come. That all what is reshaped could be deshaped also. So, this is possible only by putting these as part of sustaining system, and for this purpose, an integrated management system IMS was developed and implemented in AERB in 2018, and this is the our integrated management system level 1 document, which is available on our website. You can see that how whatever I have talked, everything is how it is brought in, that vision, mission, organizational policies, core values, and then how people will work, how decision will be made, then delegation of the decision, everything is built in. What type of regulatory clearance will go to what level of review and by who will clear it. Everything is very clearly defined, and it is a public document available, which encompasses of mission, vision, organization policies, functional mandate and organizational strategies, organizational structure and responsibilities, regulatory and management processes, decision making and communication of decisions, documentation of management system and its control, process monitoring and continual improvement. And under this level 2, if you see the application of graded approach, a well-defined thing which IAE is still struggling, but we have issued and our people are following that. Formal guidelines for establishing multi-tier review system. Now, whatever we talk about that, this safety committee, then SARCOP, and then board, how to form that committees, also well-defined guidelines and checklists are there. Not that whims and fancy, that I know you, you know me, so you are a member of the committee. No, it has to go through those checklists and they have to fill up, then only it will be approved. And there is a assessment part also, interfaces and assessment. Just a glimpse of that. Level 1 is on the website. The level 2 and level 3 are our internal procedures, which takes care of all different types of issues put together. So everything is well documented so that it can be sustained. Otherwise, whatever you think today, now you can correlate what I said, that when Apsara project was going on. When you have a person like Dr. Bhaba who knows the whole thing and 4 or 5 people only are working, then that system can work. But when you have a big organization, then you have to have a formal system, then only it can sustain. Now you see this NPPs. Nuclear power plants, we all know that we deploy that defense in depth. That is multiple levels of defense and multiple layers of defense. Now they are the mixed blessings. Why? The first one side, they greatly reduce the likelihood of an severe accident, but on the other side, they render system more opaque to people who manage and operate them. Could you gauge that what I am telling? When you have the multiple defense in depth, events will not take place. Operator will be complacent because he will not be knowing the day requirement will come, he has to act, then he will be finding himself at a loss. So one side it is a great advantage, yes, system is safe, but the other side, what it demands is you have to put more emphasis on what? More emphasis on safety culture influences. They are sufficiently widespread to increase substantially the probability of lining up and penetrate the series of defensive weaknesses. So more emphasis because of this, modern high technology, well-defended technologies such as NPPs, chemical process plants, and commercial aviation are more vulnerable to the effects of poor safety culture, poor management of human organization factors than the traditional industries. So where you have more DIDs, there you have the more vulnerability on more safeguarding against the HOF is needed, and that's why we got our all the staff trained in human organization factor. And here how finally we regulate now everything I have said. So our mission is to ensure that use of nuclear energy and ionizing radiation in the country does not cause undue risk to the health of people and the environment. For this, we do develop safety requirements and guidance documents and ensure compliance, that is license, and after licensing, you ensure the compliance with the license conditions. That is done through the two complementary processes, that is review and assessment, left side, and regulatory inspection. And this is what is takes care compared to the many countries where they are fully dependent only on this one part, that is regulatory inspection only. That's why they have the resident inspector. In our case, we don't follow this. We say that this part is very strong. So only the expanding sites we have put our resident site observers. And this question was, why not inspector? Then we say our culture is different. Our person who remains at the site and dependent on for many things on the utility, he cannot be inspector, but he can be an honest observer. He will not directly do anything, but he will observe, intimate to the headquarters, and a new person who is not knowing those people, he will come and he will enforce. So it is a cultural difference. Our system is, that's why is different than what is being followed in other countries. So this is the way we regulate. And now coming to the new initiative, which was touched upon in the beginning, we are preparing ourselves so that things can be expedited. So one is that early site review. We can have the site review independent of the design. Today it is coupled, that unless until full thing is not known, you don't start the review. But AERB is proposing this, that we can have the independent site review, give us the bounding condition, and accordingly site can be approved. Once the design is firm, then only you see the integration, how these two get integrated. So lot of time can be saved in the review, whatever goes. And similarly, early design review, that site is not fixed, but your design is fixed, we can review and we can have that design review done. Only when you combine it with the site, that time that integrated review can be done. So that can be quickly done. So this is being done. And another is this license. As on today, it is only 5 years, but we have proposed now, it is in the advanced stage, it may go to the 40 years or the lifetime as justified by the licensee, so that every 5 years renewal may not be required, but it will be a operation permit sort of a thing, so that SARCOP review will be there and it can continue. Then repeat design. Now previously reviewed and approved design, then attention only to the changes, not to the whole thing again, reinvent the wheel and again do it. If it has been reviewed and accepted, it you see that it matches with that early approved design, then no need for further review. For new design, definitely, which is not previously reviewed, detailed review and assessment, independent verification, regulatory R&D, and interaction and discussions with other RBs, these are to be done. So finally, the regulatory approach, which we have formed up based on all these inputs, AERB is mature to have an unique regulatory approach to cater to the strenuous demands of the wide-ranging technologies, inclusive, participative. In our case, that utilities are also part and parcel of our safety review process. They are members in our safety committees. In all the places they are there. But still we have not intrusive. We don't intrude into their domain. And yet independent, because that our formation functioning of the safety committee, it puts that limit, that 20% only, not more than that their representation. So the decision making remains with the AERB. Last, most important part, the two pillars of safety and striking a balance. This is what that I was telling, that technology, that regulation is a technology. This is the technology. That if you can balance out the rule-based safety, because we are bound by all act and rules, we cannot deviate from them. So all situations are anticipated, formal procedures, rules, training, implementation of scientific and technical knowledge, and this is the known technology, whatever you are doing it. So no issue, you can apply the rule based. Next one is the marriage safety, that is knowledge based safety, where unexpected situations are handled as they arise. Like a new technology comes, tomorrow SMR comes, then it is new. You are not knowing everything like rule based, you cannot directly put it. Through the knowledge based safety only you have to review it. So human expertise, quality of initiative and management comes into the picture. And these two not just coexist, but converge and develop jointly. The wisdom of this balancing comes with maturity, which AERB has acquired. So international, now whatever I said, it is that beating my drum that we have done this, but somebody else should independently see and say that, then it makes the difference. So let us see what how AERB is viewed by international community. We had an IAEA integrated regulatory review service team which visited us in initial mission in 2015. For 2 weeks they were there, and each and everything they have gone through, especially for the nuclear facilities, and their observations, just 2 points, whatever I felt relevant has been brought in. The AERB has implemented the measures to obtain the technical expertise and capabilities which may be required to support delivery of the AERB mandate. This is the first observation. Considering the power conferred by its constitution, the AERB has the necessary legal authority for its regulatory activities. The mandate of the AERB does not include any functions other than regulation of nuclear and radiation safety. This provide functional independence of the AERB as a regulator. So this says that though you are not de jure independence, but de facto independence is there, which they have verified. And after the 2015 mission, they had given 13 recommendations and 21 suggestions, for which there was a follow-up mission which came in June 2022 with the extended scope. We included the radiation facilities also. So you can see that out of 13 recommendations, 11 recommendations have been closed. Now, one recommendation relates to what they said, you have the de facto independence but not de jure. So look for that independent constitution of regulatory body, that is NSRA. Indirectly, that was the thing, so which was beyond our thing, we could not close it, which is under the purview of government. Things are being looked after by the government of India. And another recommendation was on this communication strategy, which was ready, but unfortunately it was not signed. So that was the thing, so they did not close it. So these two recommendations remain. And one suggestion on HR plan. Again, there it was only that formal signature is not there, but plan is there. So 11 recommendations closed, 21 suggestions, 20 suggestions closed. And what they observed, the IAEA team noted India's regulators showed a strong commitment and professionalism to ensure nuclear and radiation safety in the country. It is their observation, not mine. The team observed AERB has acted on all the recommendations and suggestions of the initial mission of 2015, and as a result, significant improvements have been made in many areas. The IRRS team noted a number of achievements in the following areas: improved inspection program, including enhanced training and strengthening the power of inspectors; staff qualification and training programs aimed at building and maintaining expertise necessary for discharging its responsibilities; process for regularly reviewing regulations and kites. These three were the major part they had put. And with this, I come to the conclusion part. Over the years, AERB has matured itself to an effective and vibrant regulatory body with international repute. The seed of nuclear and radiation safety, which was sown by Dr. Bhabha, has today grown into a full-fledged tree with branches spread out to control all aspects of nuclear and radiation safety in the country. AERB is now completely geared up to face the future regulatory challenges for regulating diverse design NPPs and widespread application of radiation. So I take a pride to lead Atomic Energy Regulatory Board, where the mind is without fear. Thank you very much.
Thank you so much, sir. Your thoughtful and knowledgeable remarks has indeed glorified how deployment and advancement goes hand in hand in technology. Today, we have all attained awareness regarding the Does anyone have any query regarding the address given by our speaker? Anyone?
I think it was a wonderful lecture. I think on this National Technology Day, I think this is an excellent, the award that you have given to all of us sitting here, listening to you for more than 1 hour. I just have 2 points. So one is that with your perception, we have been associated with ARB for a longer time. Are there any gap areas you feel that it is still to be addressed when you reach maturity in the regulation? This is my first point. Second point, with the evolution of the technology that is happening all over the world, digitization and more systems and devices becoming more and more complicated and complex, the cyber threat is becoming a very important thing. And this is somehow entering in everywhere, though in the formative days, we did not have that many, digitization. But today, any hacker, for example, the Kodungalam incident, people are attempting. So that is going to be one of the problem. And what are the regulatory point of view as a regulator, you feel that how this people will be trained or the stakeholder will be informed, and how are we going to address this? These 2 points.
Thank you. The first one, could you just please repeat, because
What are
I
the
lost
gap
the
areas
first.
you feel?
I think as such gap areas, if you see that our introspection, we have tried to bridge in. That main issue, what I see is that though we say that we move to the maturity, but this human resource and knowledge management, again I say, this is an area where you see that though IRRS has given us that compliment that you have the competency development, but maintaining it is a really challenge for us. I will not call it as a gap area, but for me it is a challenge, which we are looking for, that how do I take care, because if I have the very highly specialized field people, I keep like HOF. If you see, there was a recommendation which we thrown out. We simply said that we are not here to satisfy you. We have to work for our requirements, not for your. So it may be true for you, may not be good for us. They were looking for that HOF, you have the specialist available, and their specialist meaning was psychologist. In Western world, the way things are happening, that type of thing does not happen in India. That no one goes in a school and shoots out the people, or goes in a public place and shoots out. So for them, it could be. In our case, where the cultural difference is there, where the each one of us is more bothered about what is happening in the other family rather than his own family. You don't need those type of things. You will get those symptoms of any psychological deterioration of anybody much earlier than actual professionals need. So this is what is that for specialized subjects. I am finding, suppose we employ that psychologist, what will happen? He want to be having the job. Finally, he himself will become a problem for us and create more psychological problem in others. So that's why same thing is applicable to other highly specialized subjects like metallurgists. If we have a full-fledged metallurgist, continuously some 8-10 people if we keep, it will look good to show to this mission and outsider we have this. But where will be the job for him? He will have once in a while. So that part we are banking upon. It is not, I will not call again gap areas, but the challenge that we have to devise a mechanism by which we can, one is that we have entered with the MOU with BARC where we can get the all experts available right now. For them, it is easier. So they will maintain and we will tap them. So this is what we have the MOU. So this is the way we are trying, but some definitely we need, like we have that Safety Research Institute. Now people may question why it is needed. And if you need one part I had emphasized, having functional separation without isolation, and put the emphasis on without isolation. That gives me the flexibility. I don't have to create another HBNI in ERB for training my people. I don't have to do this. I can take the services of readily available thing, which is much easier for us. So we are looking from that perspective, that specialized things. So gap areas are not there. Yes, challenges are there, which we are looking with respect to the competency maintaining the competency, enhancing the competency. Yes, it is a challenge. The second part, what you talk about the cyber threat and what Kudankulam you referred. You see, first was that, let me be very upfront, tell you that Kudankulam, whatever was, it was in their administrative building, that cyber part was attacked. The preparation is two functional thing. That one is that the requirement. So that part we are well prepared, that our D25 guide is under major revision. Just we have issued the amendment for the time being, but it is under major revision. So that will take care. The first and foremost is that requirement keeps the plant safety systems totally isolated from this other cyber part, which is, it does not get connected. So chances are very rare that you have the full isolation. Then the requirements wise that people cannot come and the plant system computers, they cannot put their pen drive, or all those precautions are built in into the requirement. So, and that is being periodically checked through our regulatory inspection. So issue is not there. But what we are looking, now I am not talking as a regulator, but I am talking as a person who can understand the cyber threat and what can be done, which I had told somewhere when there was some program in NPCIL, there I had brought it out. This digital threat or digital security threat cannot be resolved by DAE alone. Now, issues are there. There are Trojans. The major part is, as long as you are dependent on getting chips from outside, you are always vulnerable. So only solution is that you have to generate your own thing. So it has to be taken at the national level for strategic projects. Like now you have analog transmitters for instrumentation. For conventional industries, people have stopped now manufacturing these transmitters. Everywhere that your digital transmitters are there, smart transmitters are there. Now what nuclear fraternity will do? They will purchase 2 items and give him 2000 requirements. You have to satisfy all these things. This is my regulator wants. So who will give you? You see, commercial orientation, they will look for, no, we don't supply to you, you go out. They will simply supply to the other companies.
System is an operating system. Or from any other.
No, that part is, no. Yeah, that source code, no. This part is taken care of. Any software being used goes through the verification and validation process. Now, problem is, if it is not developed within country, you will not have that access to verify and validate. And this is the problem when you import. So while importing, you have to look for that how verification and validation requirements will be taken care. That is what, before putting the technical assignment, check with the regulator and get clarity on the regulatory requirements, which you must include it. Many places, they may provide you the access limited, not to that extent, because Indians are known for this, no? They can replicate after coming over here. So that part, they will take care of their commercial interest, but definitely they will provide that much information by which you can ensure the same. I hope I answered your both.
Now I expect Professor Kamachi Modi.
Good evening. So it's my pleasant duty to propose vote of thanks. First of all, I thank our speaker, Sukla Sap, for giving a wonderful talk. He took us to down the memory lane of early DAE development and how self-regulation worked. And he also talked on how the establishment of AERB and what is the present status of AERB and how it works. And he touched upon all intricacies of a regulatory bodies, how they look into the different aspects. In fact, as an educational institute, HBNI, a deemed university, is under so many regulatory bodies, and we have to deal with them. And sometimes we feel it is very annoying why they are asking all these things. After attending your lecture, I try to understand what kind of thought process it has gone to those regulatory bodies to check all those aspects, which probably from our side we don't understand. That maybe there is a gap between the two. Anyway, I thank sincerely for your very wonderful talk and touching all the points and the safety aspects to work our reactors and the other radiation systems to work on in a fail-safe mode. Thank you very much. I thank our Vice Chancellor, Professor Kamachi Mudali, who talked on the importance of nuclear regulations, who talked on circular economy, and also how to increase on the reactor lifespan. I thank our Dean, Professor Nayak, who talked upon how to, HBNI has to facilitate how to transport the research, doctoral students of research can be translated into technology. And he also does that. HBN are in a position to offer many online courses if the department, certain department of a department, if there is a requirement and enough students are available, then we can design that kind of course and offer a full-fledged course. So thank you for giving all. And then I sincerely thank all the participants who is attending here in person and those who are online. And I thank for taking their time out of their busy schedule and coming here and attending all the lectures. I thank our admin team for arranging all the tea and maybe snacks, everything, and making the IT team also for making this arrangement here. I thank head HRDD and HRDD staffs also for giving this hall, for making the arrangement. And I thank you all for coming here and attending this talk. Thank you very much.